Good evening students. Today we are going to see about convolution coding. This convolution coding is an important error control coding technique which is used in the digital communication systems. This convolution coding uses convolution encoder. This encoding of message bits always done at the transmitting side of the communication system. This convolution encoder consists of a fixed length of shift register with constant length k. So consider a convolution encoder which has 3 flip-flops, say M1 and M2, and these 3 inputs M1 and M2. So these inputs are added with the binary adders. We use 2 binary adders here. So first binary adder which adds all the inputs, and the second say it is x1, the second binary adder which adds m1 and m2, say which is x2. So the output of these two are x1 and x2, and the general output marked as x, so which toggles between x1 and x2. Okay, now let us consider the message signal y is equal to 1 0 0. So let us consider a 3-bit message signal which is transmitted in the transmitting system and which is encoded using a convolution encoder. So this message bit is encoded by using a convolution tree. So what we call it as code tree. So we will draw the code tree and we will encode the output using this code tree technique. For drawing code tree, let us take a seed point A, and which gives 2 branches. Let us say the branches A and B. The branch which goes up, we call it as m is equal to 0, and which goes down, which is call it as m is equal to 1. This A leads to again branch, call it as AB, and similarly B gives the 2 branch, we call it as C and D. So A to A it goes when m is equal to 0 and m is equal to 1, A to B the branch goes. Similarly here from B to C m is equal to 0, from B to D m is equal to 1. Okay, now let us draw, this is the structure of code tree. Then again we will draw the branch of A point and B point, again C point and also the D point. Let us name it as A, B, C, D. Similarly A, B, C and D. Okay, so similarly the branch A to A which goes m is equal to 0, and here it goes m is equal to 1. Similarly here it is m is equal to 0, here it goes m is equal to 1. Similarly here it is m is equal to 0, here it is m is equal to 1. Similarly here m is equal to 0 and here m is equal to 1. Now let us draw the output for this branch. Okay, so first A to A, initially the encoder input will be 0 0. Okay, so at this branch, so let us consider at this branch the m value it goes inside. So the status of encoder will be 0 0, and this m enters here, 0 will enter here. Now we need to calculate the output x. So the x1 output will be m XOR of m1 XOR of m2. Similarly x2 will be m XOR of m2. So here at this stage the encoder status will be 0 0 0. So here the x1 will be m XOR of 0 XOR of 0 0, 0 XOR of 0 is 0. So x1 value is 0, and similarly x2 is m XOR of m2, 0 XOR of 0 is 0. So the output here it is 0 0. When you come here, the status of encoder will be 0 0 and this 1 enters here. So here x1 will be 1 XOR of 0 is 1 and 1 XOR of 0 is 1. So x1 is 1. x2 is m XOR of m2. So m XOR of m2, which is also 1. So here the output is 1. Similarly, we can calculate for this a to a. Now a to a, the m value is 0. Again this input will go outside. The status of this encoder will be 0 and 0. This m0 it will enter here. So x1 will be 0 XOR of 0, 0 XOR of again 0. So x1 is 0, x2 is also 0. So here the output is 0 0. When you come here a to b, so a to b we have already calculated, the value is 1 1. Now when you come here, the encoder status here it is 1 1, okay, and here 0 it enters. So here x1 will be 0 XOR of 1 is 1, 1 XOR of 1 is 0. Similarly x2 is 0 XOR of 1, which is 1. So the value is here it is 0 and 1. When you come here at this point 1 1, so here m is 1, okay. So here x1 is 1 XOR of 1 is 0 and 0 XOR of 1 is 1. Now if you calculate x2, 1 XOR of 1 is 0. So the value is 1 0. So the secondary, this branch we have calculated the values, output value. Similarly for a to a, previously we have calculated as 0 0, and a to b we have calculated as 1. Similarly b to c we have calculated as 0 1, and b to d we have calculated as 1 0. So at this stage we need to calculate. So the status of this encoder is 1 0. Now this m value enters. So x1 is 0 XOR of 0 0, 0 XOR of 1 is 1. Similarly x2 is 0 XOR of 1 is 1. So the value is 1 1. Similarly the status of this 1 0 and 1 enters. So x1 is 1 XOR of 0 is 1 and 1 XOR of 1 is 0. Similarly x2 is 1 XOR of 1 is 0. So which is 0 0. Okay. Similarly you need to calculate for this branch also. If you calculate for this branch, the status will be, here it is marked as 1 0. So it is 0 1 and 0 enters here. So here x1 is equal to 0 XOR of 1 is 1, 1 XOR of 0 is 1. Similarly x2 is 0 XOR of 0 is 0. So value is 1 0. For this the status is 0 1 and 1 enters here. So x1 is 1 XOR of 1 is 0, 0 XOR of 0 is 0. Similarly for x2 is 1 XOR of 1 is 1. So the value is 0 and 1. Now you need to market the input values. So first one, from this is the structure of code tree. Now you need to mark the input values, that is message values. So what is the message to be coded? First bit is 1. So from this seed point you mark it as from 1. See here where m is equal to 1. So 1 goes here. So you mark it as 1. Okay. Again you see it is 0. So 0 means it goes up. So mark it as 0. Again it is 0. 0 means which is going up. So I will mark it as here. So I will mark the encoded output, that is x. I will take it as x. So for 1 the output is 1 1, comma. For 0 the output is 0 1, and again for this it is 1 1. So for the given message bit, the encoded output will be this one. Okay, so thus by using a code tree, we can encode the given message bit as X value 1101 and 11. Thank you, students.